Unveiling the Moon, India's Chandrayaan-1 and Chandrayaan-2 expeditions. In the realm of space exploration, India has left an indelible mark with its lunar missions. Join us on a journey to explore the stories of Chandrayaan-1 and Chandrayaan-2, two remarkable missions that have deepened our understanding of the Moon. Hello, everyone. Welcome back to Business Whale Club. In this video, we'll embark on a fascinating journey into the realm of India's lunar missions, Chandrayaan-1 and Chandrayaan-2. We'll explore their remarkable evolution, from the roots of centralization to the promise of groundbreaking discoveries on the Moon. So, let's get started.
More than 1,000 scientists, more than 1 billion people, one aspiration: to witness India's giant leap to the Moon.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Nautical Society of India in 2000. The study report was viewed Chandrayaan-1 on 22nd October 2008 from Satish Dhawan Space Center, Sriharikota, Andhra Pradesh. On 14th November 2008, the Moon Impact Probe separated from the Chandrayaan orbiter at 14:36 UTC and struck the South Pole in the controlled manner, thus became the fourth country to place its flag on the Moon. Chandrayaan-1 is India's first mission to the Moon launched by India's National Space Agency.
For deep space mysteries has been going on since the evolution of the Earth.
First time the scientists have launched with so many complex technologies they have used, and they succeeded. That is historical according to me.
After travel of nearly 400,000 kilometers to achieve such a precision, perhaps it's a sort of a world record. And the anxiety before the event and the type of happiness what we have enjoyed after the event was tremendous.
Manned and unmanned spacecraft have explored the Moon. There still are several.
Chandrayaan-1, India's first lunar mission, embarked on its journey on October 22, 2008. This historic mission was launched by the Indian Space Research Organisation, ISRO, and aimed to orbit and study the Moon. Chandrayaan-1 made groundbreaking discoveries. It detected water molecules on the lunar surface, reshaping our understanding of the Moon's history. Chandrayaan-1 was equipped with 11 scientific instruments designed to study the Moon's surface and composition. Here are the details of these instruments. Number 1 Moon Impact Probe, MIP. This instrument was designed to detach from the orbiter and make a controlled descent to the lunar surface. It provided crucial data during its descent and impact. Number 2 Chandra's Altitudinal Composition Explorer, CHASE. CHASE was used to study the exosphere of the Moon and analyze the composition of its extremely thin atmosphere. Number 3 Terrain Mapping Camera, TMC. TMC was used to capture high-resolution images of the lunar surface and create detailed 3D maps. Number 4 Hyperspectral Imager, HiSi. HiSi was designed to capture spectral data of the Moon's surface, helping scientists identify different minerals and elements. Number 5 Moon Impact Probe, MIP, C1 and C2. These were additional instruments on the MIP, including a video imaging system and a mass spectrometer, used to gather data during the descent. Number 6 Moon Impact Probe, MIP, C3 and SIR2. These instruments on the MIP included a radar altimeter and a near-infrared spectrometer used to study the Moon's surface during descent. Number 7 Laser-Induced Breakdown Spectroscope, LIBS. LIBS was used to analyze the composition of lunar soil by firing a laser at the surface and analyzing the resulting plasma. Number 8 Moon Impact Probe, MIP, C4. This was an additional instrument on the MIP used for imaging and studying the surface. Number 9 Miniature Synthetic Aperture Radar, MINI-SAR. MINI-SAR was an advanced radar system designed to search for water ice on the lunar poles by mapping surface roughness. Number 10 Radiation Dose Monitor, RADAM. RADAM was used to measure the radiation environment around the Moon, which is important for future lunar exploration and habitation. Number 11 X-ray Spectrometer, C1XS. C1XS was used to measure the Moon's X-ray fluorescence, helping to identify various elements in the lunar soil. Chandrayaan-1's Moon Impact Probe, MIP, made a dramatic landing on the Moon, sending vital data back to Earth before its impact. 7 Objectives of Chandrayaan. Number 1 High-resolution imaging. Chandrayaan-1 aimed to provide high-resolution images of the lunar surface, enabling scientists to study the Moon's topography and geological features in detail. Number 2 Chemical and mineralogical mapping. The mission sought to conduct chemical and mineralogical mapping of the Moon's surface to understand its composition and origin better. Number 3 Water and hydroxyl detection. One of the primary goals was to detect the presence of water molecules, H2O, and hydroxyl ions, O, on the lunar surface. This was crucial for understanding the Moon's history and potential future lunar exploration. Number 4 Exploration of the lunar exosphere. Chandrayaan-1 aimed to study the Moon's exosphere, a tenuous and extremely thin layer of gases around the Moon, to understand its composition and dynamics. Number 5 Search for water ice. The mission aimed to search for water ice in the polar regions of the Moon, as it could potentially be a vital resource for future lunar missions. Number 6 Study of cosmic ray interaction. Chandrayaan-1 included instruments to study cosmic rays and their interaction with the lunar surface, contributing to our understanding of cosmic radiation in space. Number 7 Discovery of helium-3. Helium-3, a potential fuel for future fusion reactors, was also on the list of elements to be studied. 5 Mission highlights. Number 1 Historic lunar orbit insertion. Chandrayaan-1 made a historic lunar orbit insertion maneuver on November 8, 2008, becoming the first Indian spacecraft to enter lunar orbit. Number 2 Moon Impact Probe, MIP. The MIP was a detachable probe that made a successful landing on the Moon's surface on November 14, 2008. It transmitted crucial data before impact. Number 3 Detection of water molecules. Chandrayaan-1's Moon Impact Probe, MIP, and other instruments detected the presence of water molecules on the Moon's surface, a significant discovery that revolutionized our understanding of the Moon. Number 4 Detailed 3D mapping. The Terrain Mapping Camera, TMC, onboard Chandrayaan-1 captured high-resolution images and created detailed 3D maps of the lunar surface. Number 5 Early end of mission. Unfortunately, Chandrayaan-1's mission was cut short in August 2009 when communication with the spacecraft was lost, but its contributions to lunar science remain invaluable. Chandrayaan-1 was a groundbreaking mission that significantly expanded our knowledge of the Moon and set the stage for future lunar exploration endeavors. Next case study Chandrayaan-2 Let's Go intro.
Now Chandrayaan-2 orbiter welcomes Vikram lander. Chandrayaan-2 says, "Welcome buddy to lander."
We learned from Chandrayaan-2.
Well, India is set to head to the Moon today.
This is procedural essentially, and all along ISRO said that we're going to use the
Chandrayaan-2 spacecraft.
India's heaviest launch vehicle GSLV Mark III will launch the prestigious Chandrayaan-2. Chandrayaan-2 is the next leap.
We are going to observe a magnificent kind of like work by human beings from Earth, because we are going to reach
5, 4, 3, 2, 1, 0.
It was an historic moment for India. An unmanned spacecraft bound for the Moon successfully launched in July after a previous attempt was called off due to technical problems. Chandrayaan 2, which means mooncraft.
I mean, especially in India, which had a lot riding on this lunar mission.
Fast forward to 2019, India was ready to push the boundaries once more with Chandrayaan 2, a mission that aimed to explore the lunar South Pole, a region of great scientific interest. India's second mission to the Moon, Chandrayaan 2, was launched on the 22nd of July 2019 from Satish Dhawan Space Center, Sriharikota. Launched by the Indian Space Research Organisation, ISRO, Chandrayaan 2 was a three-part mission consisting of the orbiter, lander Vikram, and rover Pragyan. On September 6, 2019, Vikram lander descended toward the lunar surface, capturing the world's attention. Though contact with Vikram was lost during the descent, the orbiter continued its mission. The Chandrayaan 2 orbiter, armed with a suite of instruments, made remarkable discoveries. It detected water ice on the Moon and hinted at a subsurface water layer. Chandrayaan 2 showcased India's resilience and determination in the face of challenges, and the orbiter remains operational, furthering our lunar exploration efforts. Chandrayaan 2 was equipped with a total of 13 scientific instruments and payloads. These instruments were divided between the orbiter, the Vikram lander, and the Pragyan rover. Here are the details of these instruments. 6 orbiter instruments. Number 1 Terrain Mapping Camera 2, TMC-2. TMC-2 was designed to capture high-resolution 3D images of the lunar surface. It played a crucial role in mapping the Moon's topography. Number 2 Solar X-ray Monitor, XSM. XSM was used to study the abundance of key elements on the lunar surface by measuring X-rays emitted by the Moon when illuminated by solar X-rays. Number 3 Large Area Soft X-ray Spectrometer, CLASS. CLASS was designed to analyze the Moon's surface composition by measuring the reflected X-rays from the lunar surface. Number 4 Imaging IR Spectrometer, IIRS. IIRS was used to study the mineral composition and water molecules on the lunar surface by analyzing the reflected sunlight in the infrared spectrum. Number 5 Dual Frequency Synthetic Aperture Radar, DFSAR. DFSAR was used to map the distribution of water ice in the lunar polar regions and study the Moon's surface structure. Number 6 Chandrayaan 2 Atmospheric Compositional Explorer 2, CHASE-2. CHASE-2 was used to study the composition of the Moon's exosphere, specifically helium, argon, and other elements. 3 Vikram lander instruments, carried by Vikram and Pragyan. Number 1 Instrument for Lunar Seismic Activity, ILSA. ILSA was designed to measure lunar seismic activity and study the Moon's internal structure. Number 2 Chandra's Surface Thermophysical Experiment, CHASTE. CHASTE aimed to study the thermal properties of the lunar surface, including the temperature variation. Number 3 Raminder Alpha Spectrometer, ROSS. ROSS was used to analyze the distribution of chemical elements on the lunar surface. Pragyan rover instrument, carried by Pragyan rover. Number 1 Alpha Particle X-ray Spectrometer, APXS. APXS was used to determine the elemental composition of lunar soil and rocks by measuring X-rays emitted when material was irradiated with alpha particles. Number 2 Laser-Induced Breakdown Spectroscope, LIBS. LIBS was used to perform remote elemental analysis of rocks and soil by using a laser to generate plasma and then analyzing the emitted light. Number 3 Surface Alpha Particle Spectrometer, SAPS. SAPS was used to study the composition of the lunar surface by detecting alpha particles emitted during radioactive decay. Number 4 Seismometer. The Pragyan rover was also equipped with a seismometer to study lunar seismic activity. These instruments and payloads on Chandrayaan 2 were designed to conduct a comprehensive study of the Moon's surface, exosphere, seismic activity, and mineral composition, advancing our understanding of Earth's celestial neighbor. The objectives of Chandrayaan 2, India's second lunar mission, were comprehensive and aimed to advance our understanding of the Moon. Here are the primary objectives of Chandrayaan 2 to 5 orbiter-based objectives. Number 1. High-resolution imaging. The orbiter aimed to capture high-resolution images of the lunar surface to create detailed 3D maps and study lunar topography. Number 2. Mineralogical mapping. It sought to perform chemical and mineralogical mapping of the lunar surface to understand its composition and geological history better. Number 3. Detection of water ice. The orbiter aimed to search for water ice on the Moon, especially in the polar regions, and study its distribution. Number 4. Study of the lunar exosphere. Chandrayaan-2's orbiter was equipped with instruments to study the lunar exosphere, the extremely thin layer of gases around the Moon. Number 5. X-ray and infrared spectroscopy. Instruments on the orbiter were designed to perform X-ray and infrared spectroscopy to analyze the Moon's surface composition. 4. Lander-based objectives. Vikram lander. Number 1. Soft landing. The Vikram lander was designed to make a soft landing near the lunar South Pole, a region of great scientific interest. Number 2. Seismic activity. The lander carried a seismometer, instrument for lunar seismic activity, ILSA, to measure lunar seismic activity and study the Moon's interior. Number 3. Thermal properties. It aimed to study the thermal properties of the lunar surface, including temperature variations. Chandra's Surface Thermophysical Experiment, CHASTE. Number 4. Chemical composition. Instruments on the lander, including the Alpha Particle X-ray Spectrometer, APXS, Laser-Induced Breakdown Spectroscope, LIBS, and Surface Alpha Particle Spectrometer, SAPS, were designed to determine the chemical composition of lunar soil and rocks. 2. Rover-based objectives. Pragyan rover. Number 1. Surface mobility. The Pragyan rover was designed to move across the lunar surface and analyze rocks and soil at different locations. Number 2. Elemental analysis. It carried instruments such as APXS, LIBS, and SAPS to perform remote elemental analysis of lunar materials. These objectives aimed to build on the findings of Chandrayaan-1, particularly in the areas of lunar water ice detection and exploration of the lunar South Pole, and to advance our understanding of the Moon's geology, composition, and environment. Chandrayaan-2 was a significant step in India's lunar exploration program and contributed valuable data to the global scientific community. Chandrayaan-2's mission experienced a partial failure, specifically with the Vikram lander. The orbiter, on the other hand, continues to operate successfully and has made significant contributions to lunar science. Here's a summary of what happened during the mission. Vikram lander descent phase. On September 6, 2019, the Vikram lander began its descent to make a soft landing near the lunar South Pole. Everything appeared to be going as planned during the initial stages of descent. Loss of communication. During the final moments of descent, as Vikram was about 2.1 kilometers above the lunar surface, communication with the lander was unexpectedly lost. This loss of communication meant that ISRO was unable to receive telemetry and control the descent in real time. Impact. Subsequent analysis of images and data indicated that Vikram had experienced a hard landing, which means it impacted the lunar surface at a higher velocity than intended. Orbiter continues to operate. Despite the lander's difficulties, the Chandrayaan-2 orbiter was unaffected and continues to orbit the Moon successfully. It has been carrying out its intended scientific observations and sending valuable data back to Earth. Reasons for the Vikram lander failure. The exact reasons for the Vikram lander's failure to make a soft landing were not initially clear, but subsequent analysis and investigations by ISRO suggested that a technical issue during the descent phase was likely the cause. Some of the factors that could have contributed to the failure include navigation and guidance anomalies. An anomaly in the navigation and guidance systems during the final stages of descent may have caused the lander to lose its orientation, leading to a deviation from the planned trajectory. Throttle control. Issues related to the throttling, control of engine power, during the descent could have played a role in the final descent phase. Communication issues. The loss of communication may have prevented ground controllers from making real-time adjustments to correct any issues that arose during the descent. ISRO conducted an extensive analysis and investigation to learn from the Chandrayaan-2 landing attempt and apply the lessons to future lunar missions. The mission's orbiter continues to provide valuable data, and it demonstrates the complexity and challenges of soft landings on celestial bodies. It's important to note that lunar exploration missions often involve high levels of risk and complexity, and setbacks are not uncommon in space exploration.
Vikram lander descent was as planned and the normal performance was observed up to an altitude of 2.1 km. Subsequently, the communication from lander to ground station was lost.
Both Chandrayaan-1 and Chandrayaan-2 have cemented India's position in the elite league of lunar explorers. They represent the nation's unwavering commitment to scientific advancement. As we continue to look to the skies and beyond, Chandrayaan-1 and Chandrayaan-2 stand as testaments to India's remarkable journey in the world of space exploration. These two missions have significantly advanced our understanding of the Moon, but they are just the beginning of India's lunar odyssey. Chandrayaan-1 and Chandrayaan-2's contributions continue to reverberate through the scientific community. The wealth of data they collected has opened new avenues of research. Scientists from around the world have used their findings to uncover secrets about lunar geology, its history, and the potential for future lunar exploration and habitation. Moreover, these missions have spurred international collaboration. India's expertise in space exploration has led to partnerships with space agencies and institutions worldwide. The legacy of Chandrayaan-1 and Chandrayaan-2 serves as a launching pad for future lunar missions. India is gearing up for Chandrayaan-3, with the goal of a successful lunar landing. Chandrayaan-3 aims to build on the lessons learned from its predecessors, once again showcasing India's ambition and commitment to lunar exploration. And there you have it, the incredible journey of Chandrayaan-3, India's relentless pursuit of lunar exploration. Don't miss the video Chandrayaan-3 and end screen and other space exploration endeavors. Subscribe to our channel for more fascinating content about the cosmos and the limitless possibilities of human exploration. As we look ahead, the Moon continues to beckon with its mysteries, and India stands at the forefront of the global quest for lunar knowledge. In the vast cosmos, India's Chandrayaan missions remind us that the human spirit of exploration knows no bounds. Thank you for joining us on this celestial journey. Until next time, keep reaching for the stars. As we conclude this journey through the ever-evolving world of science and technology, we're reminded of the boundless potential for innovation that surrounds us. The future holds countless possibilities, and it's driven by the relentless pursuit of knowledge, discovery, and progress. Stay curious, stay informed, and never stop exploring the frontiers of science and technology. Don't forget to like, share, and subscribe to our channel for the latest updates on groundbreaking discoveries and technological marvels. Thank you for joining us on this exhilarating journey through the fascinating world of science and technology. Together, we'll continue to shape the future. That's a wrap for today's video on C. I hope you enjoyed it and gained a clearer understanding of this exciting concept. If you have any questions or want to learn more about a specific aspect of Moon, please leave a comment below. And as always, stay curious and stay tech-savvy. See you next time on Business Whale Club. Make sure you don't miss it. Hit that subscribe button and the notification bell so you'll be the first to know when our next video drops. Remember, as we venture into the exciting realms of science and technology, always stay curious and keep seeking knowledge. Take care of yourself, and I look forward to our rendezvous in the next video. This is your channel, and until then, farewell. Goodbye.